Hello, my name is Brian Markey. I'm an instructor at the Los Angeles Trade Technical College, bringing to you 40 years plus of experience in the heavy-duty truck and bus field. I'm here to pass on some of this knowledge to you to help make your job easier and more fulfilling. Always remember during this presentation and when you're working to work smarter and not harder. Make your job as easy as possible. This presentation is the Heavy-Duty Air Brake Systems Bus Air Brake Pneumatic System Training, brought to you by LA Trade Technical College and the Transportation Workforce Institute. Presentation slide overview. We're going to discuss the physics associated with the air brake system, the law, system layout and design, airline color codes, fitting identification, pneumatic schematics, supply system operation, supply system components, control system operation, service and parking brakes, accessory systems, control system components, and component testing. Braking physics. Pressure times area equals force. Pascal's law. Area times length, which creates the AL factor. Force applied to a lever, that creates torque. The coefficient of friction, torque, heat, and braking balance. First, we'll start with pressure times area equals force. P times A equals F. Force is created by applying pressure to an area of specific size. Always remember you can increase the force by increasing the specific pressure applied to a given area while maintaining the size of the area, or you can increase the force by increasing the size of the area while maintaining a constant pressure. At this point, I always like to reference so you get a better understanding things like door motors and other related parts. You'll notice in a pressure differential motor, there are two different size pistons, and the way they work is we send the same pressure, say for round numbers 100 psi, to an area that has a given dimension of 2 square inches. 2 square inches times 100 psi is going to give you 200 pounds of force. On the other side of the motor, you'll have a given area of 4 square inches. We send that 100 psi to the 4 square inch area. That creates 400 pounds. So as an example, 400 pounds applied. We have 200 pounds of constant pressure on the small piston side. What we end up with is 200 pounds of force keeping the door closed, and we override that 200 pounds with 400, so that gives us 200 pounds to open the door. That's just an example of how you can increase the force by increasing the size while maintaining a constant pressure. Now in the air brake system, we use the opposite. We have a constant size, which is typically, say, a Type 24 or a Type 30 brake chamber. With that, we apply a varying amount of pressure. So say we apply 100 psi to a Type 30 brake chamber, we end up with 100 times 30, 3,000 pounds of linear force. The same applies to a Type 24 brake chamber. We end up with 24 times 100, nice round numbers, and we end up with 2,400 linear pounds of force. Now, in the braking system, it's important to understand that the pressure is varied by application valve pressure. Most brake applications take place between 10 and 20 psi of pressure. 10 pounds of pressure multiplied times 30 square inches is going to give you 300 pounds of force, and conversely, 20 pounds, 30 square inches, going to give you 600 pounds of force. So most brake applications take place at low pressure. In this slide, we have a Type 30 brake chamber, which has an effective area of 30 square inches, and we're going to apply a pressure of 100 psi. That 100 psi is going to push evenly on all surfaces of the brake chamber and cause the diaphragm to balloon over to the non-pressure side, pushing on the piston, which in turn pushes on the push rod. So we have 100 psi times 30 in area is going to give you 3,000 pounds of linear force. That 3,000 pounds of linear force will push on the slack adjuster or the brake adjuster, causing the vehicle to stop. Now, in most brake applications, it's 10 to 20 psi, so we have to change the pressure to 10 psi times 30 inches of effective area, 10 times 30, 300 pounds of linear force. And as the pressure goes up, our area remains constant and the pressure varies, increasing or decreasing the linear force. Pascal's law. Pascal's law says pressure within a given area is equal on all surfaces of the area. An increase in pressure within a confined area will result in an increase in pressure on all surfaces of the confined area. In other words, as we increase pressure in, for example, the room you're in, the pressure is going to increase on all the surfaces of the walls, you, the table, anything that happens to be in that room. So, keep in mind with Pascal's law, there is no high and low pressure areas. Anytime in the air brake system we increase pressure on all surfaces of the area. Newton's law. Newton's law says a body at rest remains at rest and a body in motion continues in motion. Objects in motion want to stay in motion. When the brakes are applied, the bus wants to continue in motion even though the wheels are slowing down. Now we can divide this into two different sections. Short and long wheelbase vehicles. Short wheelbase vehicles have their primary brakes on the front wheels, where long wheelbase, the primary brakes are on the rear wheels. The primary brakes are usually the larger braking force in the vehicle. What happens when you apply the brakes on a small vehicle such as your car or your pickup truck? The wheels want to slow down as the braking takes place on the wheels or through some sort of brake retarding. Bottom line is we want to apply the primary brakes with a greater force than the secondary brakes. Now, on your short wheelbase vehicle, when we apply the brakes, the vehicle itself, the body wants to continue in motion while the wheels slow down, causing the body to move forward. And as the wheels slow, the weight of the body is transferred to the front axle. That's why we have larger brakes in the front. Now, on a long wheelbase vehicle, the same thing happens. When we apply the brakes, the body wants to continue forward, but due to the length, it is going to want the rear to come around to the front. That's called jackknifing. We don't want the rear to pass the front. So in a long wheelbase vehicle, we apply the rear brakes with a greater force, or we pull the vehicle to a stop. On a short wheelbase vehicle, we push the vehicle to a stop. So that's where Newton's law comes in, is an object in motion wants to remain in motion until an opposite force or the brakes are applied. Always remember, on a long wheelbase vehicle, the primary brakes or the larger brake force is on the rear because we want to pull the vehicle to a stop to keep it in line. On a short wheelbase vehicle, cars, pickup trucks, motorcycles, the weight's transferred to the front fairly rapidly, and because it's so short, we want to apply the front brakes at a greater rate than the rear brakes.